A warm welcome to all. In today's video, we will continue the part 2 series of corrosion. So, I am Dr. G. Kirtika, Assistant Professor of SRM Institute of Science and Technology, Chemical Engineering Department.
Next, we can move to corrosion control techniques, like how to protect corrosion. So, what are the strategies which we can use to save our material from corrosion? So, the corrosion control techniques include two types. So, the first one is surface conversion coating. The next one is cathodic protection. So, the first one deals with protecting our material by means of anodizing process, by means of phosphating process, and also by means of galvanizing process. The second one is making our material as a cathode and saving the cathode so that the anode sometimes may get corroded, or the anode can be inert to prevent the corrosion. So we shall discuss these techniques one by one. First, coming to surface coatings. So in surface coating, the first process which we can study here is anodization. So what is surface conversion coatings? As we discussed, the outer surface of the base metal is converted into protective coating through appropriate chemical modification. So anodizing is a process where the outer surface of the metal is coated with this proper oxide layer. It can be aluminum oxide layer or chromium based coatings or any other such type of coatings. So first, this process involves a few steps. So the article is cleaned, degreased. Yeah, so we can see the image over here of anodizing process. So we can keep our job work is the material in which we have to anodize. It is taken as an anode, and the cathode can be any inert material, or it can be steel, copper or aluminium. The temperature of the bath is maintained at 35 degrees Celsius, and electrolyte can be chromic acid for making for oxidation process, or it can be sulfuric acid with some inerts or fillers. So here, next step, the outer layer of our aluminium will become aluminium oxide, and this process is known as anodizing. So you can see some of the application of the anodized product, like whatever we use in our day-to-day life is mostly anodized. Example, computer hardware, roofs, floor, ceilings, curtain, escalators and commercial buildings undergo the process of anodization. Next is phosphating. In phosphating is also a similar process to anodization, where here a phosphate coating is applied on the surface to protect our material, converting the metal surface of the atoms into their phosphates, corresponding phosphates, like iron means iron phosphate and similar other phosphates by chemical or electrochemical reaction is known as phosphating. The phosphating bath has main three essential elements, like free phosphoric acid should be there to maintain the pH of 1.8 to 2, and the metal phosphate should be there. Whatever metal we want to deposit as a phosphate, like magnesium phosphate, iron phosphate should be there, and an accelerator such as hydrogen peroxide. This hydrogen peroxide is a buffer which is added to maintain the pH in the system, and also some nitrites and nitrates. So here we have a schematic of the steps of phosphating processes. First is degreasing. The metal is degreased by by washing, and it is followed by prickling process, rinsing, phosphating, and also the followed by the reaction and drying. So steps in phosphating, as we see there, we can take the article or the metal which has to be phosphated as the anode. The other material can be the cathode. The electrolytic solution can be a combination of phosphoric acid with boric acid and also some of the additive agents. So the article is clean, degreased and polished. Steel or copper is used as a cathode. When direct current is applied, the metal ions combine with the phosphate ions to form a metal phosphate. So you can have a metal phosphate layer on the desired metal. So this process is known as phosphating. It improves the corrosion resistance, and also it impacts good adhesion property to the interface. Example of phosphating can be like an underlayer of the primary coat, and you are phosphating your car bodies, refrigerator and also your washing machine. So this all these spare parts undergo a phosphating process before being fitted to the major components. So followed with the surface coatings, we have the metal coatings, which is known as galvanizing. So what is galvanizing? As we understood, Galvanizing is a process of coating of a metal surface with zinc. Okay, so it is done by hot dipping method, and also it has a series of steps which involves a prickling process, a descaling process, and also a degreasing process. So when we see in detail, so what is the prickling process? Prickling is the surface of the metal is washed with dilute sulfuric acid to remove the acidic or any grease or oil or dust on the surface. So this is known as a descaling process. And further, next to this process, the oil and grease which is on the surface of the spare parts can be removed by washing with organic solvents such as CCl4 and toluene. This is known as degreasing process. Finally, the article is washed off with water and it is air dried. So the article is dipped into the molten zinc, and this is known as a flux. So to prevent the oxidation of the molten zinc, ammonium chloride is added in the bath. Okay, the excess of zinc is removed by passing through the hot rollers. So we can see the process of hot dip galvanization process. Like it undergoes the process of caustic degreasing, washing with the acid prickling process, and then it is dried, it is water rinse so that the material is neutral, like material is not acidic in nature, the material is ready for coating of zinc. Say for example, any steel rolls or steel structures. So it is dipped in the zinc bath. Okay, by coating a zinc flux, it is dipped to the zinc bath at a temperature of 35 degrees Celsius, and the excess zinc is removed and it is quenched into the process of chromic acids. So galvanization, where we can see the galvanization process. Galvanization can be seen in roofing sheets, fencing wire, buckets, bolts, nuts, and pipes. Coming to the next process of protecting our material from corrosion is cathodic protection. So here we have two steps. One is sacrificial anode method and the other is impressed current method. So in cathodic protection, the metal to be protected is completely converted into cathode. So it doesn't, so that it doesn't undergo corrosion and the metal is protected against the corrosion. So let us just see the example of sacrificial anode method. So here the concept is the metal or the pipe or the tube or your reactor which has to be protected is electrically connected to a more active metal. Okay, then so when the steel is to be protected, it is connected to block of magnesium, zinc, etc. So the steel will behave as a cathode because it's more it's less active. Steel is less active, and your magnesium is more active. So magnesium is prone to corrosion, so magnesium will start to corrode. It will decay, like it will what to say, it will undergo sacrificial corrosion. So over a period of time we need to check and monitor so that the magnesium can be or the zinc strips can be replaced, and we ensure that our steel is protected as cathode. So here you can see the example, the object. So any tube or any steel structures, any pipes to be protected. So that material is supposed to be act as a cathode, and we place the other material which is prone to corrosion, like magnesium, zinc, which is more active material for corrosion, has been placed as an anode. So in this process, we are forcing this material as an anode. So anode undergoes corrosion, and the opposite material, which is our desired material, is saved as cathode. Here, the important phenomena we have to observe is no power source is used here. Okay, this is the only difference from the next method. Example, you can see the magnesium blocks are connected to the buried pipelines, and also magnesium bars fixed to the ship as sacrificial anode. Next is impressed current method. So this also follows the same procedure, but it is slightly different from sacrificial anode method. So in the impressed current method, the metal to be protected is connected to the negative terminal of the external DC supply. So you take a DC power, and whatever material has to be protected, you make that as the protector structure as a cathode by applying negative potential. Then the positive potential will act as an anode. Here the anode is not most active metal. The anode is an inert material like graphite or any other material, can be carbon material, can be chosen as your anode. So you're protecting your cathode by making it as a less active material, and but instead instead of undergoing corrosion of anode, you're also saving your anode by putting a positive charge. So this DC supply will ensure that always this cathode structure is in the negative potential and doesn't undergo corrosion, and the positive potential is taken up by this anode. Since anode is inert, this anode also will not corrode, so that this will remain protected for a longer time under seawater. So this type of method is known as impressed current method of corrosion prevention. We shall next move to the topic of protective coatings. This is also a method of saving or protecting our desired material from corrosion. In protective coating, we have a layer of material is applied on the surface of it. It's like mostly like painting. So we apply a good layer of a material as a coating to save our material, to prevent our material from corrosion. A protective coating can be metallic or non-metallic. So there are variety of methods of coatings, and nowadays in market we have long life coatings for our buildings and also for many structures, which helps to retain the desired characteristics of our the painted material. So the protective coatings are applied to a variety of methods, and it can be used for many other purpose besides corrosion. Non-metallic coatings can be polymer coating, epoxide coatings, polyurethane coatings are available in the market to protect and prevent corrosion. So the metallic coatings can be zinc, aluminium and chromium. So we can see a small example where the substrate, the desired material, it can undergo a different types of coatings so that it is protected from corrosion. So the first is pre-treatment, which is also ensures that it is corrosion protection. The second one is primer, which ensures that it is corrosion protected, and the top coat is for the barrier protection. Means it prevents the corrosion barrier, and it also enhances the appearance. So you can give a layer of coating to protect your material from corrosion. So here is an example of magnesium alloy substrate, which is prevented from corrosion by numerous layer of coatings. Next is prevention of corrosion from Pamban Bridge. So this is a very good example where we all know about this Pamban Bridge. So Pamban Bridge is of about 2.2 kilometer. It establishes a connection between Dhanushkodi to Mandapam. So here we have the ferry movement where the steel structure can open up to 90 degrees, and also this is one of the oldest bridge connecting two parts of the city. Now, what is the challenging here is this is always under stress because it is under the sea water and sea current, and it is subjected to humidity, cyclone and salts which is present in the sea water, and it is highly prone to corrosion. So this structure has to be protected so that the rail communication can be established. So here, expert people has suggested to protect the Pamban Bridge by using a special painting scheme which has a lifetime of 35 years. So they are using a newly developed polysiloxane paint, which is developed by using burger paints, where they use an universal epoxy primer followed by a coating of acrylic polysiloxane paint to protect or to increase the lifetime of these bridges. So as I said, here the real challenging situation could be to protect the bridge from continuous sunlight, cyclic weathering, high humidity, and also from the natural calamities. So we can see here we could establish the rail connection if, by protecting the bridge by using suitable protective coatings. Thank you.